Welcome back to Geometry Classroom. Today we'll continue our lessons regarding a compound probability, and we'll talk about probability of two events, right, linked by word or. We have here a few specific, right, special cases. The probability of event A or B when events A and B are independent events. The probability of events A or B is the sum of the probability of each event, right? That's the formula. Another case is refers to mutually exclusive events. Mutually exclusive events are events that cannot happen at the same time, right? If one of the events happens, the other one is impossible to happen, and vice versa. If event A and B are mutually exclusive, right, events, then P of A and B equals 0, right? Because it's impossible to have both events occur. Yeah? Now, when we have such a case, P of A or B equals P of A plus P of B, the probability of event A plus the probability of event B. Another special case is for so-called inclusive events or overlapping events. Inclusive events are events that are not mutually exclusive, yes? These are events that can happen at the same time. We can have such a case. For example, when calculating the probability of selecting a diamond or a face card from a deck of cards, there are three mutually inclusive events, right? For example, picking a jack of diamonds, a queen of diamonds, or a king of diamonds, right? All of these events are possible, right? Good. When we have inclusive events, the probability of including inclusive events or overlapping, right, is given by this formula, right? P of A or B is the sum of probability of event A, the probability of event B, and this sum, right, from this sum we subtract the probability of events A and B, or the overlapping events. Yes? Now, let's have a few examples with finding the probability of event A or B for different cases. In this example, a die is rolled. What is the probability of rolling a 1 or a number greater than 3? Now, remember, we have to identify each event first, right? The first event, or event A, is getting a 1 when we roll a die, right? This is event A. Event B is getting a number greater than 3 when we roll the die, right? This is event A. As we can see, A and B are related by word or, right? Good. Now, what kind of events are? Because it's important. Remember, if the events are mutually exclusive, the probability of P of A or B would be the sum of the probability of event A and event B. But if the events are overlapping, we have a different formula, right? Now, I think it's easy to see that these two events are mutually exclusive. Why? Because if you get a 1 when you roll a die, you cannot get a number greater than 3, and vice versa, right? Now, it's simple. Now, P of A or B would be P of A plus P of B, right? So, let's find the probability of each event. What is the probability of getting a 1 when you roll a die? Is 1 out of 6, right? Because you have only one face with number 1. Yes, there is only one possible favorable outcome out of 6 possible outcomes. Plus, how many favorable outcomes are for event B? In other words, how many numbers greater than 3 you have when you roll a die? We have 3 such possible favorable outcomes. Why? Because you have 4, 5, and 6. These are all numbers greater than 3. So, on top of the fraction, we put 3, right? Out of, again, 6 possible outcomes. Of course, we can add these fractions. Why? Because they have the same denominator. So we keep the denominator and we add tops. We have 4 over 6. And of course, we can reduce the fraction or simplify the fraction to 2/3. Yes? Another 2 examples. What is P of A or B if P of A equals 1/3 and P of B equals 2/9, where A and B are overlapping? So this time we know what kind of events are. Because they are overlapping, we use the formula for overlapping events, which is P of A or B equals P of A plus P of B minus P of A and B. Yeah? So, P of A and B, yes, because these two events are independent, we can replace P of A and B by the product of P of A and P of B. So we're going to have P of A plus P of B minus P of A times P of B, right? So let's find P of A or B. Would be 1/3 plus 2/9 minus 1/3 or 2/9. First, let's express the last term, rewrite as 2 over 27, right? We multiply tops and bottoms. Now, in order to be able to add and subtract then these fractions, we have to find the common denominator. The common denominator is 27, right? Now, to get 27 here, we have to multiply both top and bottom by 9. So, we get 9 over 27, right? Plus, to get 27 here, we multiply both top and bottom by 3. So, we're going to have 6 over 27. And then the last fraction is as it is, minus 2 over 27. Right? Now, we should be able to combine these fractions by keeping the denominator, and then by adding 9 and 6, which is 15, and then subtracting 2, which is 13. That's the probability of event A or B. Now, another example. It says a spinner has 5 equal sections numbered 1 to 5. What is the probability of the spinner spinning on a number that is a multiple of 2 or is less than 3, right? Again, we have 2 events. The first event is getting a multiple of 2 when you spin the spinner, right? This is A. And the second event is getting a number that is less than 3, right? And as we can see, these events are related by word OR. Now, what are the possible favorable outcomes for event A? Is only 2 and 4, right? Because you cannot exceed 5, yes? The possible outcomes, favorable outcomes for event B are 1 and 2 only, right? But as we can see, these events are overlapping. Why? Because they have an outcome in common, which is 2, right? Yes, we have to keep in mind. Because they are overlapping, we use the same formula, right? This formula. So, we say P of A or B would be P of A. In this case, we have 2 possible favorable outcomes, right? So you're going to have 2 over 5. Why? Because 5 is the total number of outcomes or possible outcomes. Plus, what is the probability of event B? Is the same, right, as the probability of event A. Why? Because we have 2 possible favorable outcomes, right, out of, again, the same number of possible outcomes. Now, what is P of A and B? In this case, P of A and B cannot be P of A and B. Why? Because we have a different case here, right? So, in this case, we have to find the number of all possible favorable outcomes that are common, which is only 1, right? Because only 2 is a common outcome for both events. So you're going to have minus 1 over 5, which is, again, the total number of outcomes. As we can see here, we keep the bottom, right? Because the bottom is the same for all fractions. And then add 2 and 2, which is 4, and subtract 1, which is 3. So that's the probability of the spinner stopping on a number that is multiple of 2 or is less than 3. So that's all we have for today. Thank you for watching my video.